should get started with the class. Are there any questions from last time? Nothing? It's all good? No questions about the homework assignments? Yep.
You sent an email out recently about the homework assignment. Could you elaborate a little more on it?
Yes, I can. Let me log in to the website first, and then we can go in. Basically, most of the class got it right, get full points, which is just 5 points. Yep, go ahead.
On the homework that we have for this week, because in the example that you did in class, it was just for one condition that we were evaluating, but in the homework there was an AND operator, so I wasn't sure how you wanted us to show that in the actual spreadsheet.
Okay, you just say, the entire expression, and then say it is true or false. That's basically what it is. So you don't need to tell me, which side of the AND is true and which side is false. You just tell me the final answer of the entire expression. Okay, so is that...
Don't we use the up arrow as an indicator of AND?
You can just spell out AND, A-N-D. You can just spell it out if you want to.
It's also correct to use
If I understand it, it's good. If you use the if you use the caret symbol, I can still recognize it as the mathematical AND symbol, and that's still fine. Okay. So let me log in and talk about the homework assignment that I graded over the weekend, I think. And there were a few. I was not planning to talk about it because I sent an email regarding that already, but since someone asked, I should go ahead and talk about it. Okay, so some people did not use the document linked from the assignment. Okay, that's part of the instruction. Download this document, okay, and use it as the basis, for the homework assignment. So from now on, remember to do that. Okay, you have to start with the document linked from the homework assignment. And some other people do not use OpenOffice to edit it, and I can tell. Okay, because certain features of the original document would have been preserved if people used OpenOffice. If someone uses Excel to open a document and save it again using Excel, the same feature will be gone. So that's how I can tell people were not using OpenOffice to edit the document. Now, the good thing is this assignment only carries 5 points. Okay, so what is 5 points in the grand scheme of things? You will probably eventually accumulate up to maybe 300 points or so only for homework assignments. What is the proportion of homework assignments in your final grade? Nobody remembers from the syllabus? 20%, okay? 20%. In other words, 5 points out of 300, and then 300 points only make up 20% of your final grade. So what is the actual percentage of the final grade that is impacted by this 5-point homework assignment? 5 divided by 300 times 20%, okay, which is a very, very small number. If anyone at the end of the semester cannot make it to the next grade because of this homework assignment, I can take a closer look, but I don't think it will make any major impact to anyone's final grade. In other words, this assignment is really just a warm-up to make sure that people understand the process, okay? So there are 2 main points. One is to use OpenOffice, and the second one is to start with the document that is linked from the assignment itself. Okay, so those 2 are very important because from now on, I will hold you guys, onto this part here and make sure that everybody will follow these rules. Are there any questions? The interesting thing is in this class, not a single person put the name on the first sheet. Everybody put it onto the second sheet. Some people did not start with a document, but they still put the name on the second sheet at cell A1. My Friday class, on the other hand, had maybe 4 or 5 people who put their name on the first sheet, cell A1. So that's kind of interesting. Probably has something to do with what I talked about in the class because no person in this class did that. So that's kind of interesting. So is that okay? I mean, did I cover the topic well enough? Okay. So the grading of this homework assignment was somewhat strict. It's either all points or none, because, it's only 5 points. I don't even bother to give partial credit for something like that. It's really just an exercise to make sure that people understand, how to, do the homework assignment from now on. because from now on we'll start to have more interesting homework assignments, so to speak. Okay, so we'll go back to this topic here, and I can also tell that there are 19 views of the video clip that I captured last Thursday, which is good. Okay, that means some people are checking out YouTube and watching the lecture again. I also found that some people have not watched or have not read or have not clicked on some of these links from the Moodle site. I do not take any points off. I do not use that for grading purposes or attendance purposes. But it is somewhat important, I think, for everyone to read the notes, ahead of time, or if not ahead of time, at least after a class, review what I have gone over in the class. I know some of you come with some programming background and you already know most of this stuff. It still helps to kind of go over that, material again. So I'll start to pass the worksheet around. And today, we'll start with the more complex pseudocode example here, and we'll go ahead and trace this program. Has anyone traced this by hand, on your own? You don't have to raise your hand, if you don't want people to think that you are an overachiever. Trust me, that is not overachieving, okay? Not quite. Okay, you should actually do that because, the rest of this node is already doing a trace here, okay? In other words, all you have to do is to read this node here, and you should know approximately what's going to go on when this code executes. What I'll do is I'll just do the boring thing, but instead of reading my own notes, which I cannot do, I'll go ahead and use my spreadsheet here to capture this. And because the program is already here, I won't even bother to use sheet 1 to capture the algorithm because the algorithm is already on the website. So I'll just go ahead and start with the trace itself. If anyone has any question at any point, be sure to ask those questions because this is a fairly important topic. First of all, we need to label all the columns. The first one is comments because we do have conditions to evaluate. We have 2 loops here. Line 3 is the beginning of one loop. Line 5 is the beginning of another loop. And then we need to indicate the line number. And we also need to use 1 column per variable. How many variables do we have? We have x, y, and then we have sum, which is s. So we have 3 variables in this particular case. So you just say x, y, and s right there. And you can also shrink some of these columns so it will all fit nicely. Like this. Okay. And line number can also be shrunk a little bit. So this way, things are going to be a little bit more tight and it's easier to read. Okay. So the first thing is, what do we use, as our precondition? We use unknowns. Okay. X, Y, and S, they all start with some unknown value. But that's okay because each one will be initialized before it is used first. So that means we will never refer to these unknown values when we need to perform calculations. And let me double check and make sure that I am recording from the right input. Nope, it was not. Okay, so that means I have to double check on this. Okay, it is now recording from the right channel. Okay. We start execution on line 1. And what do we do on line 1? X gets a value of 0. Very good. And X is the only one that gets affected. On line 2, S gets 0. So that's easy. On line 3, what do?
Evaluation.
We evaluate the comparison. So we spell it out and say x is less than 3 as an expression. Is it true or is it false?
True.
It is true. With a while loop, where do we go next?
4.
We go to line 4. Very good. Line 4 is going to initialize y to 0. Now here, right here, it is important to realize that the initialization of y is not on line 1 or line 2. It is on line 4. The difference is these 2 variables, x and s, they all get initialized before the loop once. They never get reinitialized. Variable y, on the other hand, will get reinitialized for every iteration of the outer loop. Okay, every time we go back to the beginning of the outer loop, and every time we execute line 4, it gets reinitialized. Okay, that is very important because sometimes we want to reinitialize things at the very in the loop, and other times we only want to initialize exactly once before we get into the loop. And now we go into step 5. Step 5 evaluates another condition. Y is less than 2 is true. Very good. Okay, now we go to line 6, right? Because if the condition of a while loop is true, we go into the body of the loop to perform one iteration. So at this point, I don't think anything is really suspicious or anything is really tricky. Y gets y plus 1. Y had a value of 0. 0 plus 1 is 1. And then we update y to be 1 at this point. Then we go to line 7. Line 7 is basically calculating the sum of all 3 variables. X has a value of 0, y has a value of 1, and s has a value of 0. 0 plus 1 plus 0 is 1. And then we use that to update the variable s, and it is now having a value of 1. Are we doing okay so far at this point? Okay, going forward is relatively easy, but now we are at a point where, well, potentially there are 2 places to go, or 3. Okay, if based on misunderstanding of this algorithm, there can be like 3 places that we can go. So the question is, where do we go next? We are at the end of a loop.
You go to the immediately preceding while, because that's what it's looping from. So you go to line 5.
Exactly. Okay, that is exactly right. We have to go back first. Okay, so the first thing is, this is not a conditional statement. If this were a conditional statement, in other words, if line 5 said, if y is less than 2, then that is a one-shot deal. Then we get out of the conditional statement, and then we continue on to line 9. But it is not a conditional statement. If it is a loop, we always have to go back to an earlier point. Knowing that we have to go back to an earlier point, this is end while, so it is telling us, it's hinting us that we have to go back to the beginning of a while. But we have 2 while loops here. We have a while on line 5, we have another while on line 3. So the question is, how do we know which one we are supposed to go back to? It is not just the most recent while, it is basically the most recent unmatched while. In other words, if you look at while as open parenthesis and you look at end while as closed parenthesis, this is how we match things up. Okay, when you close the parentheses here, you have to find out which one is the opening for it, and that's where you go back to. But visually, how can we look at this code and say, oh, just visually, I can tell exactly where we're supposed to go back to?
Matching indentation.
The indentation, very good. In other words, if you put a ruler, I don't have exactly a ruler, but if you have a ruler and you just line things up vertically, you can see that, well, this is white, so it doesn't really show too well. Let me see if I can find something that is not exactly white. Off-white. Okay, so if you have a ruler, you can see that the indentation of this while on line 5 and the end while of line 8, they match up exactly. And that's a visual hint to tell you that on after line 7, we have to go back to line 5. So this is really important because it shows you, nesting code really is not any different from non-nesting code because you just go back to the while that has a matching indentation. We go back to line 5, and line 5 still has its same thing to do as before. Y is less than 2 is still true because y is 1 at this point. Then we go to line 6 again. Y gets incremented to 2, but we do not get out of the loop at this point. Okay? We will get out eventually because y is 2 at this point, but we cannot get out because line 6 has nothing to test. Is that okay? Right? The only job of line 6 is to change y. It does not make a decision whether it is time to get out or not. If it does not have a decision to make, we have no choice but to continue on to the next statement. Since this is line 6, the next statement is line 7. Line 7, once again, will compute the sum of all 3 variables. In this case, it is 0 plus 2 plus 1 and the sum of that is 3. And then we have to go back to line 5 again. Now, I know some of you can look at this and say, oh, we have to get out of the loop at this point because y has a value of 2. But you cannot just get out and go to line 9 at this point because we have to explain why we are getting out. So that means when you're tracing this algorithm, you have to indicate that we are getting back to line 5 first, except in this case, the condition of line 5 evaluates to false, and that is why we get out of the loop and end up on line 9 after that. Are there any questions up to this point about this trace here? No questions? Okay. Now that we are on line 9, we'll do what line 9 tells us to do, which is incrementing x by 1. X goes from 0 to 1. And then where do we go this time? We go back to line 3 because line 3, the indentation of line 3 matches the indentation of line 10, which is the close of the outer loop. So that's why we have to go back to line 3 here. Line 3 is going to reevaluate x is less than 3, and that condition is true because x has a value of 1 at this point. Then we go back to line 4 because if the condition of a while loop is true, we have to perform another iteration. On line 4, it reinitializes y to 0. Okay, it had a value of 2 already, but since we are re-executing line 4, now it is updated to 0 again. That is very important, okay, because it depends on where you put that line. If I put line 4, y gets 0, to, let's say, line 2.5, somewhere above line 3, then it will only get done once. But since I have it inside the loop, it is now getting done every single time we get back to line 4. Are there any questions at this point about this loop here, or this nested code? Questions? The rest of this is somewhat boring because I think I have covered all the really important cases here. But I can still at least illustrate how to use this little bar here. Okay, let me just do it all over again so that you guys can see what I just did. Okay, at least with a screen like this, with 1024 by 768 as its resolution, and I have to bump up the magnification to 150%, I cannot give you the entire spreadsheet at the same time because otherwise people in the back will not be able to read what I'm typing. So as a result of zooming in, I now run out of room. I would not have enough room. I'll have to scroll. But when I scroll, this stuff is going to scroll off the screen, so I cannot know which column is which variable anymore. One trick you can do is to pull this little thing here down a little bit, and this separates the screen into 2 different scrollable areas. The first part can scroll on its own, and then the second part can also scroll on its own. Now this is a really, really handy feature, especially when you run out of space on the screen, because it can keep the header of each column in view while you work on additional columns, so that the header of each column does not get out of view. Are there any questions about this particular feature in OpenOffice? You can do the same thing with Microsoft Excel. Since even though we don't use Excel in this class, if you have to use Excel for other classes, for other purposes, and you run out of space and you cannot really see the header of the column or the rows, this is a nice little trick that you can use. So getting back to this algorithm, after line 4, we get to line 5. Line 5 is not really that fun anymore because we kind of know what it's supposed to do. Then we go to line 6. Y gets y plus 1, goes from 0 to 1 again. We go to line 7, which is a summation of all 3 variables. 1 plus 1 plus 3 is 5. Then we go back to line 5, because line 7 is the last line of the inner loop. We go back to line 5. We reevaluate the condition of line 5. It is still true because y has a value of 1. 1 is less than 2. Then we go back to line 6 again. Y gets incremented to 2. When we go to line 7, we compute the summation of the 3 variables. Gets up to 8. We go back to line 5 again. Y now has a value of 2. 2 is less than 2 is false. We move on to line 9. We add 1 to x. X goes from 1 to 2. And then we go back to line 3 again. Line 3 evaluates the expression x is less than 3. It is still true. So you can see that the rest of this algorithm is fairly boring, because we already know how to handle, the case of nesting.
It's just going to keep doing that?
It will keep doing this until x, has a value of 3, and then when we go back to line 3, the condition of line 3 will then become false, and then we get out of the outer loop. Okay. So are there any questions about this trace at this point, especially the explanation of what to do after line 7 and what to do after line 9, because those are the trickier places where, mistakes can be made. No questions? Okay. All right. If there are no questions, I will not finish this trace. I think you guys should try to do that. Okay. In other words, you can either take this document, which I will save later today, and upload it to the website, or you can just copy and paste the one from the class note itself and try to finish it up. It is not something you have to turn in. It's not something that I am going to grade, but I think it will still be beneficial if people finish that last one iteration of the outer loop. Okay, so we'll go ahead and save this file in today's folder. And I forgot that I cannot create folder for some reason outside of here. So I'm going to create a folder here, 2011-0201. File exists. So I did create the folder. Oh yeah, I did it earlier. So we'll go ahead and find that folder and save this file. Nested loops. Okay. So after this, we have the next slide is basically the same thing. It's just a hint of how do we interpret the end of the loops, which is the most important part of this particular note here. And that's the end of nested statements. Are there any questions of any of the topics that we have talked about so far? Because we are pretty much at the end of topic 2. We talked about variables, expressions, and sequences. In other words, every time you see a statement following another one without any if, then, else, or while, or repeat until, they are sequential. We talked about conditional statements and conditions, and also logical operators like and, or, and not. We talked about loops, while loops and repeat until loops, otherwise known as pre-checking loops and post-checking loops. And then we also talked about nested statements, basically how do you run the code when you have one statement that is completely inside another statement. So are there any questions about these topics before we move to the next one, which is going to be a nasty one? No questions. We're all ready for the next challenge. Okay, so I will change the highlight to make sure that we all understand that topic 3 is now the current topic. Topic 2 is kind of a thing of the past. Oh, no, I guess not topic 3. We'll move on to topic 4. You guys cannot see topic 3 anyway because it's all grayed out. Topic 4 is somewhat nasty because it talks about pre and post conditions. Now we have kind of used that concept when we trace algorithms. We used pre to indicate what do we know before we execute an algorithm. We use post to indicate, oh, we are all done. There's no more steps to perform, after this. So pre and post are used in that context, but when we talk about this particular slide, pre and post conditions take on entirely different meanings. So make sure that you remember that topic 4 has nothing, absolutely nothing, to do with tracing algorithms. Okay? Whatever we learned about tracing algorithms will not be useful in topic 4 anymore. Tracing will still be useful later on, but not for this particular topic. We'll go ahead and take a look at pre and post conditions. And this one starts with this slide here. I'm not going to read it. Obviously it's going to be boring to read what is this crazy math. Because this chapter, or this topic here, will have some kind of crazy math depending on the background, the math background of people. Some people will say, oh, this is pretty easy stuff because I know all that stuff already. Other people may say, I did not know that I need to understand mathematics to become a programmer. So when you read this part here, you will see that the first slide does not have anything that is technical. It's basically a debate of two giants in computer science. One guy is called Esther. I think is the S silent?
Yeah, I think
Yeah. So Edgar, right? Just Edgar Dijkstra, and he is. Is it a Dutch name? I think it's around that part of Europe. But this person has this Dijkstra guy has died already. But before he died, he suggested a programmer should become a mathematician first. Okay, in other words, computer science, technically speaking, should be treated as a branch of mathematics, just like applied math, just like calculus, just like maybe statistics. So it should be a branch of mathematics. Another guy who is also a giant in terms of computer science is Donald Knuth, and he is still living. He is still teaching at Stanford. Okay, and his take is a little bit different. He claims that with sufficient advances of tools, everyone should be able to program computers or write programs. You may not be programming a computer. You may be writing programs on your cell phone. You may be programming your VCR, but everybody should be able to program something. So you have these opposing schools of thought. One is saying, you need to have really rigorous training in mathematics before you can start to program, and the other one is saying, no, that's not true. Everybody can program a VCR. Okay, now VCR obviously is a thing of the past already. What do we have now instead of VCRs?
DVR.
We have DVRs. Okay, very good. So what is the difference between a VCR and a DVR in terms of programming? In terms of I want to record some shows. Okay. With a VCR, what kind of flexibility do I have?
You're limited by the cassette tape that you would use in the VCR.
Okay, but in addition to that, what kind of limitations do you have when you program a VCR? You have time, you have day of week, you have the time of the day, you can also program with a specific day, but you generally speaking, you cannot have rules. Okay, the rules, if anything, would be fairly simple. I want to record from this time to this time from Monday to Friday, okay, weekdays. Or I want to record daily from this time to this time, or I want to record only on Tuesdays every week from this time to this time. So fairly simple rules. What about DVRs? Does anyone know how to program a DVR? What kind of flexibility do you think a DVR will offer that a VCR does not have, never had? Go ahead.
Something like when you're recording new shows.
Mm-hmm.
Every show that comes at that time.
So it can actually understand, the program itself, because the program information is received by your television. So your television or your DVR actually understand the schedule, the TV guide and stuff like that. It actually understands that. In other words, if a show is going to repeat a few times over a week, and you want to record this show, and this show, and there may be conflicts, the computer or your DVR can resolve the conflicts and reschedule the recording and say, okay, if I record it this way, and this way, then there will be no conflict. I can record all 3 shows without any conflicts. Okay, so there's some intelligence to it already. But you can also record by keywords and also the name of the show. Okay, it depends on your DVR, but some DVRs allow you to specify, I will record every show that has this word as a part of the name of the show, and this word as a part of the description of the episode, and so on and so forth. So what are we doing now? We are getting back to logical operators. Okay, you're getting back to and, you're getting back to or, we are getting back to negation not. And you can combine those things in a nested way, just like you're using parentheses. So suddenly, just programming your DVR, went from programming a VCR to a programming class. Is that? Are you guys, seeing what I'm trying to say? Well, but that's not surprising. What is your DVR? It's a computer. It's a computer pretending to be a DVR. It tries its best to hide its computer nature, but it is a computer of sorts. Okay, so it's not surprising that it can understand all that logic. All the Boolean expressions, all the conjunctions, disjunctions, all the negations, And guess what? If you're really good at programming, you can also use regular expressions. Okay, we are not going to talk about regular expressions in this class, but it's a really powerful technique to look for certain patterns of words. Okay, so in other words, you're not looking for an exact match anymore. You can look for things that match a particular pattern. And if you can combine regular expressions with a DVR recording program, then you have a very flexible way of specifying what you want to record. Okay? All right. So getting back to this slide here, I don't think anyone is going to make money being a professional DVR programmer. Maybe in the future somebody can make money out of it, but I think it's not a very reliable job. So the question now is, many of you are in the computer science track, others are in a engineering track, and some are on the math track. So the question is, okay, let's just say that we are all on the computer track, computer programming track, in terms of getting a job, okay, and keeping your job. What do you think math has anything to do with that part, that particular aspect of your career? Do you guys still remember 2000? Year 2000, the dot-com boom, where people are getting really well-paid jobs in the Silicon Valley. I was a part of that boom. I had a job, a consulting job in Palo Alto. I had to drive down there, every Thursday. At around, I have to get there by 7 o'clock for meetings, for conferences. But in order to get down there by 7 p.m., when do you think I have to leave Sacramento? 4 p.m. is pushing it. Okay, typically I want to leave at 3:30 or so because the drive is really long because I will hit traffic dead on. Okay, and then I'll have a 1 hour meeting. So after 3 hours of drive, I'll have one hour meeting. And then usually we go to an Indian restaurant for about an hour and a half to talk about stuff that is not related to business. And then I'll have another 2 hour and a half drive back from Palo Alto. Okay? But that's okay because it was well paid. Okay? And I only have to do this once a week. Okay? I know people, from UC Davis, undergraduate students, who were pulled by their, professors to work on that job too. They provided, a place to live, okay, and the workplace has lots and lots of perks. Okay, we're talking about not just soda or coffee, at work. I'm talking about catered lunch. Okay, not cafeteria kind of catering. I'm talking about expensive catered food for lunch, and dinner, and massages. If you feel kind of stiff that day, just tell your boss, and he'll get someone to give you a good massage. They will have someone to help wax your car while you work. In other words, you have no excuse to leave that place. That's the whole idea. They want to keep you there. You want that expensive errand chair that will cost like $1,000? No problem. We'll get one the next day. Okay. Everything is overnight. Okay, that's the dot-com boom. And during the dot-com boom, was any one of you a high school student at the time? No? Okay. Okay. So do you remember, some of your classmates, getting jobs during that boom? Maybe?
People I knew growing up, they got jobs.
Mm-hmm. And in the Bay Area, it was even more the case. Okay, they finished recruiting all programmers that are already experienced, so they had to go to high schools to recruit high school students as programmers. Okay, which is okay. And some of those students, I'm not saying all, but some learned how to program just by using a book called, let's say, PHP for Dummies, that has a CD-ROM with all the sample code. And some of these people, I'm not saying all, but many of these people could only, copy and paste code. In other words, they read the book, one page or one chapter says, okay, this chunk of code will do da-da-da, and okay, my boss just asked me to do da-da-da. Well, I don't really exactly, understand that chunk of code. I'll just copy and paste it and change the variable names to match the rest of the PHP, script and call it a day. Okay? And there were people like that. They were getting jobs. They were getting well-paying jobs. And then after that was the dot-com bust. Okay. Now the bust, came in many. There were many reasons why there was a bust. But for the most part, the venture capitalists were not getting the return. They were not getting the money, which is they expected a 1 to 10 ratio. Okay. I put out $1 into one of these. There's a name for these new companies, startups. Okay. So they put in $1 into the startup. They expect $10 back. Okay. And many of these startups did not turn did not produce any profit. They do not produce anything. And of course at this point the VCs or the venture capitalists have to pull out all the funding, and there goes the errand chair, there goes the massage service, there goes their job. And guess who gets to keep the jobs? Well, the ones that are good, okay? The good programmers. So the question now is, what differentiates a good programmer from a mediocre or bad programmer? What is the differentiation?
Strong math skills.
Good logical skills, good math skills. Okay, but why would that matter? I mean, programming is programming, math is math. How do they relate to each other? Problem solving. Okay, very good. And just generally speaking, the application of logic. Okay. But on the job, let's say you are the boss of a company that does a lot of programming, and these days we are going to see another boom. What is fueling the next boom in terms of programming jobs?
Social media.
Apps.
iPhone apps.
Yep. iPhone apps, Android apps, and so on. That's going to fuel the next boom. It's not going to be as much of a boom of 2000, but there will still be a boom. So let's say you are the supervisor in charge of a team of programmers. How do you evaluate your programmers? Skill, that's kind of vague. Okay, let me give you a few choices. Number of lines that person can crank out each day. Would that be a good metric?
Quality of lines.
I can write a lot of lines. The question is, do they actually work, right? So that's not a good way to determine whether someone is a good programmer or not. How about number of bugs that person fixes a day? Well, on the surface, it seems like a good metric, but it's not. Okay. Does anyone read Dubert? Yes, some of you. Okay. There was one time they had this story. The pointy-haired boss, which is the boss of Dubert, said, okay, for every bug that the team catches or each person catches, there will be a reward of X amount of dollars. Okay, and Wally, which is the kind of like the really nerdy and shady guy, always coming up with schemes and whatnot. So Wally, went back to his cubicle and said, I'm going to write myself a minivan. So what did he mean by that?
It was loaded with bugs. He was purposely creating.
Exactly. So now, Wally can fill the number of lines requirement as well as number of bugs caught per day requirement. But nonetheless, there's no productivity whatsoever. Okay? I would say a good programmer would be one that can catch bugs more effectively. I think that's one really good metric to determine whether someone is a good programmer is, given the same bug, how much time would that person take to figure out what the bug is and how to fix it. Okay? Now, that's somewhat different from copying and pasting from PHP for Dummies, don't you think? It requires a different set of skills. So what we will talk about here with pre and post conditions is not exactly going to fix every problem, but it will develop the skills necessary to debug programs more effectively. Okay? That's the context of what we are talking about in this particular chapter. So the next thing we talk about are the pre and the post conditions. A precondition, if I want to explain that in just one sentence, is what we know before the execution of a statement in a program, but expressed as a condition. In other words, the condition can be as simple as x is less than y and z equals to 5. Okay, that's an expression. A post condition is also just a condition, but it tells us what we know after the execution of a statement in a program. That doesn't seem too hard. So let's go ahead and start with some simple cases, just so that we can get an idea of what we are really talking about here. So let's just say that we have line 479 here. Okay, so this is one line out of a really long program, and that line has the code that looks like this. Okay, this is the code on that line. X gets the value of, let's say, 45. For some reason, I know the precondition of line 479 is, well, let's start with something easy. Okay, let's just say that I know x equals to a value of 23. Don't ask me why. I was told. Okay, the precondition in this case is a condition that I was told. I was never told why, but let's say I can trust it. In other words, before the execution of line 479, in this case, I know for sure that x has a value of 23. What would be the post condition of this line? X equals 45, because line 479 is going to overwrite the value of variable x to exactly 45. It's not a big deal. We know how to deal with this. It makes sense. Okay, does it make sense? Okay, so not a big deal. Let's try something a little bit more, difficult. Let's try, I don't know. Let's try line 317, and this time we'll have y gets a value of 15. Okay, and let's just say that before line 317, the precondition of that is just saying that x equals to, we'll pick some value, 67. Okay, that's it. That's all that I knew before line 317 executes. So the question now is, what is the most specific condition that I can say regarding line 317?
X is equal to 67, y is equal.
Aha, very good. So we know that the value of x would not have been changed by line 317, because line 317 does not change x at all. X is not the variable on the left-hand side. But on top of that, regardless, even though we knew nothing about y before this line, guess what? We now know something about y, because this line explicitly put a value of 15 into y. So that's why I can also use a conjunction and say that y equals to 15. Is that making any sense? Yes? Kind of? Not really? Okay, that's good. So we have handled, a few, cases like this. Okay, not a big deal. That's good. Now let's talk about something that is even more interesting. Let's say 211 has a line that says something like this: y gets y plus 1. Okay, and in this case, let's say the precondition of line 211 turned out to be, I don't know. Let's say y is less than z. Okay, that's all that we know about y before line 211. What do you think we can say about this whole thing as the post condition of line 211?
So y is 1 more than it was, and then it's at least 1
Z is
less.
greater than or equal to y plus 1.
Sorry?
Z is greater than or equal to y plus 1.
That is correct. There are several ways to say this. One way is to say it as y minus 1 is less than z, which is equivalent, exactly the same thing as z is, which is the same as saying y is less than z plus 1. Is that making any sense? Okay, this one I think we have to slow down maybe a little bit and just make sure that everybody can understand this part here. Okay, let's just start this whole thing again. Before line 200, immediately before line 211, we know that y is less than z. That's all that we know. We don't know what z is. We don't know what y is. We just know their relationship. Y is less than z. Okay, that's all that we knew. Line 211 is going to add 1 to y. In other words, y is now 1 more than it was before. Is that making any sense? So that means y minus 1 after line 211 will get us back to the value of y before line 211. Is that making any sense? because all line 211 did was to add 1 to y. So if we refer to the value of y after line 211 and say, oh, take that value and subtract 1 from it, we get the old value of y back. Is that okay so far? Well, since we knew that value was less than z, we now can say the same value is less than z. Is that okay? Fair enough? Okay, so this part may need some time to sink in. So if you're not understanding this whole thing completely, you might want to read the notes and just kind of spend some time on it. Some of this stuff may you can spend some time to kind of let it sink in a little bit. Now, if I can say y minus 1 is less than z, I can say y is less than z plus 1 because I can add 1 to both sides of the inequality and preserve the relationship. So that part is just algebra. Are we okay with this one? Okay. Well, this is kind of interesting because we can work on these individual cases independently. But the question is, can we look at a assignment statement and determine which template we can use in order to derive the post condition from a precondition? That's the question. Can we have templates to do everything? Why do I want to have templates? Well, templates make it easy. Okay, it turns everything into a mechanical process. Now, why do we want to have mechanical process when we are dealing with stuff like this?
Basically, programming, it's the thing that goes between the precondition and the post.
It also makes your job easier. Okay, if I give you a particular assignment statement, you look at the assignment statement. If it fulfills certain requirements, okay, we use these rules to go from the precondition to the post condition. If it fulfills the other set of rules, then we use the other rule to go from the precondition to the post condition. In other words, it makes it easy to look at any statement and be able to derive the post condition from the precondition. Okay, is that making any sense so far? Now, let's go ahead and try something else. So what we'll do, the first thing I will do is to go to this slide here. And it's taking its time to, okay, it just loaded everything. So in this case, I have a constant assignment algorithm. All it does is to change the values of x and y, repeatedly. So it's a really easy program to trace. But remember what I said a little bit earlier? This topic has absolutely nothing to do with tracing anymore. Okay, we're not tracing anything anymore. If you read through this section here, you will see that, we start with some really peculiar precondition. The precondition of line 1 is true. Okay, so let me just copy everything into this note here. And I will just use another example, not exactly the same, but close enough so that it can still be used to illustrate the same points. Okay, this is my program. This is my algorithm. If I say pre1 is true, what am I really saying? I'm saying that the precondition of line 1 is just true. Does it say anything about x? Does it say anything about y? Does it say anything about how x and y relate? Nothing. In other words, this is saying that I don't know anything about x or y. There's no assumption that can be made. Is that okay? I'm just starting with no assumptions about the value of x or the value of y before line 1 executes. Okay. So how do I derive post 1? Well, post 1 is fairly easy. I mean, if you guys just look at the code here, what does it do? Okay, x becomes 4, and that's the only thing that we'll know. Okay? And what do you think is pre-2? Exactly. Now, how do we know that? I mean, why do we know that pre-2, the precondition of line 2, is x equals 4? Exactly, because the two statements are sequential. If they're sequential statements, then the precondition of the statement after is the same as the post condition of the statement before. Is that making any sense? Okay, when two statements are sequential, we can use this rule, so there's no derivation at all for pre-2. Okay, well, what is post-2 then? Okay, x equals 4 and y equals 2. Now, it is very important to state the conjunction, because if you use a disjunction here, then it would not be exactly right. Because if you use a disjunction, it is not as restrictive. We always want the pre and post conditions to be as restrictive as possible so that we can say more about what we know about that condition. Okay, and what is pre-3? Okay, pre-3 is post-2, and in this case, it is exactly the same as this condition, this conjunction here. Now, post-3 is a little bit interesting because we cannot ditch the whole thing, and we are not going to change the whole thing. We have to keep whatever we know about y, because line 3 does not change y. But we have to forget everything that we know about x, because x is now updated to a value of 5. Is that making any sense? Okay, so we'll do that. We'll just say that y equals 2. We can keep that part because we are not changing y, but at the same time, x equals 4 has to be forgotten because we are now changing it to x equals 5. Why can't I say x equals 4 and x equals 5? Well, let's think about it. Okay, so this part here is wrong. So remember, I'm typing something that is wrong here. What does that mean? That means the entire expression has to be false. Because x equals 4 and x equals 5 cannot be true at the same time. And yet, this is a conjunction. So that means the entire thing cannot be true, and that defeats the whole purpose of using a pre and post condition construct. So that's why we have to remove x equals 4, because it is no longer equal, it does not equal to 4 anymore. Yep?
When we're talking about our first precondition being true, we just assume it's true, right? Because there's nothing to...
Because a precondition has to be true. Okay? Now, there are cases where a precondition is false. We'll talk about that when we get to conditional statements. We'll basically talk about a concept that we have talked about already when we talk about what happens when a precondition is false, because it corresponds to a dead branch. So we'll get to that part later. For now, we only have sequences, really simple statements to evaluate. So are we doing okay so far with this? Yes?
So why can't you say in post 1 that x equals 4 and true?
That is, okay, that's a very good question. Okay, the question is, how come we cannot preserve what is in pre-1 that does not mention x? That's your question, right? And the answer is, yes, we can do this. Okay, I did a simplification without letting you guys know. Okay, what is true and x equals 4? Well, let's go back a little bit and talk and think of what is conjunction. Okay, and we can look at conjunction in a few ways. Okay, in this case, I'm looking at it as a truth table. A truth table is exactly what the name implies. It is a table that shows you the truth value of every single column. We know that x can be true, it can be false. We know that while x is true, y can be true, y can be false. While x is false, y can also be true, y can be false. So now we have 4 possible combinations of true-false values as input into the conjunction. What is true and true? True. True and false is false. False and true is false. False and false is false. Okay, well, we know this already. We talked about this. This is also the common understanding of conjunction used in a natural language. I don't really care about the entire thing, because what I want to do is to look at this particular format here. True and something that can be true or can be false. Okay, so we want to take a look at that. So that means we want to focus on these 2 columns here, or these 2 rows. True and true is true. True and false is false. That's a little bit interesting, because when you look at what happens when x itself is true, when y is true, the conjunction is true as well. When y is false, the conjunction is false as well. Don't we have a similar concept in multiplication?
Positive and negative.
Easier than that. It's easier than that. 1 times 3 is 3. 1 times 5 is 5. 1 times n, I don't even know what n is. Is n.
You're talking about the identity property.
Exactly. True is the identity with respect to conjunction in Boolean logic. Okay? So, if you have an equation like this, 1 times 3 is 3, 1 times 5 is 5, 1 times n is n, which means it can be simplified. Don't you think we can do about the same thing over here? True and whatever is that whatever. Okay? Because true is the identity with respect to conjunction. So when you say true and whatever, the answer is always that whatever on the other side. So that's why. So that's a very good question because I skipped that step intentionally because I didn't want to bring this up just yet. But that's good because now we know why it can be. This rule is really nice because you can just borrow whatever is from the precondition. Anything that does not mention the variable getting changed can be preserved. Okay, very good. Are there any questions at this point? No questions? Well, I want to kind of bring ourselves back to an earlier question, the context of all this stuff. I mean, obviously, this is Boolean algebra. Okay, Boolean algebra is how you manipulate operators in Boolean logic. What is Boolean, by the way? Because every time I throw out a term that you do not understand, you should ask.
False, 0, 1.
But why do we call it Boolean?
That means bool.
Yep, exactly. So Boolean algebra is a logic calculus of true-false values or truth values in general, and it is developed by George Boole. Okay, and that's why it's called Boolean, algebra, like Newtonian physics, because it's summarized or put together by Newton in that case. So in this case, it's put together by the person called Boole with the first name of George. Okay. Just to tell you guys what the name means, because you will see this term over and over again in programming classes. Okay. But Tech, why do we have to do all this stuff here to become good programmers? But let me ask you, do you think algebra is useful in programming? Or in anything that has to do with numbers? Well, for the same reason, Boolean algebra can be useful because we have to express logic in a program. That's why knowing Boolean algebra can also be very, very helpful when you write programs. Okay, but getting back to this slide here, we want something that is rule-based. Okay, so let me tell you what the rule is now. Okay, the rule. This is what I call the forget rule. Okay, the forget rule is quite simple. What it says is, if the right-hand side of an assignment, for now we'll make it very simple, does not refer to the variable on the left-hand side, then use the forget rule. Okay, well, but I still haven't explained what the forget rule is. I just know when to apply it. The forget rule is like this. Okay? So the precondition of, the post condition of something. Let me give you a general thing here. Okay, so we'll have line n here. This is, I don't know which line I'm talking about. I just know it is line n. I don't know what x is. It's just a variable. I don't even know what expression is. expr is the expression on the right-hand side. So the thing is, if expr does not refer to x, then we can use the following derivation. The derivation is simply to say that the post condition of line n is the forget operator applied to the precondition of line n with respect to variable x. But at the same time, after the forget operation, we say x equals to the expression. That's the rule. Now this part is not in the notes. Okay, I should really update the notes so that it matches, this new interpretation. But I just thought of it, 30 seconds ago, so that's why it's not in the notes. Every time I teach this class, I learn something new. I learn a better presentation of the same material, and that's why it's not in the book. Okay, so exactly what does that do? Okay, forget pre-n x is just a text operation to forget all components of pre-n that mention x. That's basically all that it does. But this is really, really abstract. We don't know what n is, we don't know what x is, we don't know what expr is. But that's the whole point. The whole point of this is to make it so abstract that you can look at any assignment statement and you can assess, one, whether I can apply the forget rule, and two, when I do have to apply the forget rule, what does it do? Okay? So that's why this whole thing is quote-unquote abstract, is because it is intended as a rule, so you can apply this rule whenever it is applicable. So that you don't have to look at every single assignment statement on a very individual basis. We can use these rules to determine what to do. So what I'll do next is to give you an example, okay, a real solid example. We'll just say that on line 35, we have an expression. We have a real variable in this case. So we'll just use the real variable as, let's say z is our real variable. And we'll just say that, in this assignment, we'll pick something that's, not too complicated. We'll just say that z gets a value of 7. And for some reason, someone told me that I can assume the precondition of line 35 is x equals 3 and y is less than z and w is greater than x. Okay? This is a precondition of line 35. Don't ask me why the precondition of line 35 is like this. It was derived from earlier steps. Someone told me, but I know this is true for sure. Okay? That's all we know. So now, how do we apply that rule? First of all, we look at the general format of the assignment statement. In other words, in this case, we look at line 35 or the 35 as n, because n represents the line number. In this case, we have a solid line number. It is 35. We look at this x here, which is a placeholder of the variable on the left-hand side. So this time, z is the variable that we are talking about. And we also look at expression, expr, which in this case is just simply the constant 7, because that is the expression on the right-hand side. Are we doing okay so far? Matching components of the rule to this particular example that we are dealing with. Okay? So once you match up, n, x, and expression, the first question is, can we even apply this rule? In other words, does expr refer to x? Does the expression on the right-hand side refer to the variable on the left-hand side of the assignment? No. 7 is 7. It does not refer to z. So that means we can, in fact, apply the following derivation. Okay, so that's fine. We'll go ahead and use the derivation. The derivation is saying the post condition of line 35, because n is 35, remember, is the application of the forget operation based on the precondition of n. What is n again? 35. Very good. And what is x this time? Z. Very good. And what else can we do? We can also express, after the conjunction, that x equals to expr. What is x again this time? X being a placeholder? Z. Okay, very good. And expr is 7. Oh, that is kind of cool, because that means that once we can match the format of the assignment statement to this general form, evaluate this condition. Does expr refer to x? and we know that, oh, EXPR does not refer to X, then we can just write the post condition just like this. The next step is a little bit more cumbersome, because in the next step, you have to expand the actual precondition. In other words, you have to say, oh, so what are we talking about when we talk about pre-35? Well, this is why I like using a notepad instead of the whiteboard, because I can copy and paste, and you cannot. But I will save this file too. I will save this file into today's folder, so at the end of the class, if someone reminds me to do it, I will upload this file to the Moodle website, and you will have everything that I talked about in this class, plus the video clip that is, also on YouTube after this class. Okay, and the rest is just Z. Now, it is important in this case, let me just make this a little bit longer. This pre-35 here is expanding to this part here, because we know pre-35 is that expression. The Z is the variable that is of interest to us, because we are going to overwrite the variable Z. And the rest is just, Z equals 7. So the big question is, what are we doing when we say forget blah, 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 comma Z? Well, we're just forgetting all the components that mentions Z. So of these three comparisons, which one mentions something about Z?
Y.
The middle one, right? Y is less than Z. Well, since we did not really know what Z exactly was, we only knew that Z was greater than Y, and now it is changed. We can't really know whether Z is still greater than Y or not. The relationship between Y and Z is gone. There's no way I can derive that condition again. So that means after the forget operation, we keep whatever we knew about X by itself. We keep whatever we knew about W and X, because we never modified these two. But whatever we knew about the relationship between Y and Z has to be forgotten, because I just changed the value of Z. But on top of everything, even though I lost one thing that I knew, I still get something new, because at this point, I know for sure immediately after line 35, Z will have a value of 7. Are we doing okay so far with this derivation? So what are the 3 steps? The 3 steps are basically just 1, check to see if you can use the forget rule. Okay, if the expression on the right-hand side does not refer to the variable on the left-hand side, then you can use the forget rule. The next thing to do is to look at this template here. Okay, N is the line number, X is the variable name on the left-hand side, and EXPR is the expression on the right-hand side. Just copy everything. Okay, in this case, we have the variable name being Z. Here, we have line number being 35, and then we have the expression being 7. In other words, you make a match of the placeholders, you expand everything out. The only thing you have to do in that case is when you carry out the actual forget operation, you have to kind of do it on an individual basis, because different preconditions will have different components. Is that okay so far? Yes, kind of? Okay. So now, let's just do one more exercise. Yep, go ahead.
So when it refers to X, like expression, how do you tell when it does it refer to the variable?
Well, let's go ahead and try this one. Okay, we'll go back and try these examples that we have had before. Oh, maybe we'll try this one instead. Sorry, I changed my mind. Okay, so we'll go ahead and paste that right here. And of course, I still need to know the precondition, just like that. Okay, so this is my new case to deal with. Okay, the precondition of line 1 is true. The expression is this. Okay, so we go back and we say, can we even apply the forget rule? Well, let's take a look. The general form to match is like this. In other words, in this case, n is 1 because that's the line number. Lowercase x is the name of the variable. It will take the place of the placeholder uppercase x. The expression on the right-hand side as a placeholder is now replaced by a constant of 4. Are we doing okay so far? You're matching up all the components. Once we match up all the components, then we can answer the question. Do you think EXPR, the right-hand side of the assignment, do you think it does it refer to x? Does it refer to the variable on the left-hand side? Nope. 4 as a constant does not refer to lowercase x. So that means we can use the forget rule. So what do we do when we apply the forget rule? Well, when we apply the forget rule, we say the post condition of the line that we are dealing with, in this case line 1, is the result of a forget operation. The forget operation will take the precondition of the same line and will forget everything that mentions the variable on the left-hand side. The variable on the left-hand side in this case is x. But after this, we can also say something about the variable on the left-hand side, because now we know for sure it equals to the value on the expression of the right-hand side. In this case, it is 4. Are we doing okay so far? In other words, I just reapplied the rule to a different case. Okay? So the next step you have to perform is to actually expand what is pre-1. Now, pre-1 can be complicated like the one that we just did earlier, or it can be as simple as this, true. So if it was true, just true itself, you just say true, okay? You don't change it. And then you go ahead and actually perform the forget operation. Does true as a value refer to x? No, it does not. So that means we can keep it. So now the whole thing about forget is not really forgetting anything, because true does not refer to x, and therefore we don't have to forget it.
Why doesn't it refer? How come it doesn't? When you say it does not refer to x, 4 does not refer to x?
4 does not refer to x. X plus 1 refers to x. X times 2 refers to x. But 4 as a constant does not refer to x. Okay? So now we have t and 4 equals 4, and because of this we can simplify the whole thing and just say the whole thing is x equals 4. In other words, it comes to exactly the same answer, but this time I'm going through a very mechanical process to first determine, can I apply that rule? And 2, when I do apply that rule, what are the components that get into the different places of this application of that rule? So this is a mechanical process. I just turned something that was on a case-by-case basis into a mechanical process. And that's always a good thing in programming. I don't know about art classes, okay, but in programming, we like things that are predictable, we like things that are mechanical, we like things that are black and white, and we like things that are rule-based. Okay? Are we doing okay so far with this? Okay? So this is all good. I'm assuming that most of you understand, at least have a general idea of what the forget rule is about and when to apply it. What about something like this? What if line 5 is x gets x minus 1? Do you think I can apply it, or should I apply the forget rule in this case? No. I cannot, okay? Because if I did apply the forget rule, I would end up with x equals x minus 1, which is not a good thing. Okay, x equals x minus 1 is always false. So that means, with something like this, because the right-hand side refers to the left-hand side, I need something that is different. Okay? So what if the right-hand side does refer to the left-hand side? We cannot apply the forget operation. Okay. Well, we have about 5 minutes left, which is not enough time to cover the entire substitution operation, but it is just enough time to cover what is an inverse function. Okay, I know some of you probably have taken classes and you know what is an inverse function. How many people know what is an inverse function? Okay, about 1/3 of the class. But that's okay, the rest of the class, you don't have to worry about a single thing, because I can explain what is an inverse function. The first thing to explain is what is a function, f of x. Okay, f is called a function, and it is applied to x. I can define function f like this as, let's say, x plus 1. Okay, well, what it is really a shorthand. A function is basically a shorthand from this perspective. I know in mathematics, a function has a very, very specific meaning, but in this class, we'll just use a general meaning and just say that this is shorthand. Well, x plus 1 is not something that will take a long time to type, but what if I have an equation that is this long? Okay, well, saying that f of x is, x plus y, the whole thing squared, times 3x divided by the sine of x times da 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 da. Hey, if I can refer to the whole thing as f of x, it's easier, which is good. So in this case, I'm just saying that every time you see f of x, it means x plus 1. If you apply f to something else, okay, let's say we apply f to 4, you just replace x by the value of 4, so f of 4 is actually the value of 5. Okay? Are there any questions about what a function is from this simple perspective? No questions? What if I have something like this? What do? You just expand the function one level at a time. So what this means is, it is, you take whatever is inside the outmost parentheses, you take that, and then you say it is whatever that plus 1. Okay, well, that's good. I got rid of one f. So now I have another one here to take care of. Okay, so you take that out, and you say it is whatever the thing plus 1. But remember, this whole thing is f of 1. So now we have this. And now we have just one level of f to apply, which only has a parameter or argument of 1. So now it becomes 1 plus 1 plus 1 plus 1. The whole thing becomes, 4. Is that okay so far? Okay, so functions can nest because whatever you do is you don't care. Okay, the thing is, you don't care what is inside the parentheses. You take whatever is inside the parentheses and say, I'm just adding 1 to that. If it is x, I'm adding 1 to x. If it is 4, I'm adding 1 to 4. If it is f of 1, I just add 1 to f of 1. Okay, is that okay so far? And we have 55 seconds left. I can now explain what is an inverse function. Okay, the inverse function of f, in this case, is x minus 1. Now, what is the special property of an inverse function? Now, in this class, we use f prime to indicate what is an inverse function because it is easy to type on the keyboard. Okay, in your calculus class, f prime of something is the first derivative of that function. So make sure that you don't make that mistake, mixing up the two classes. If f prime of x is the inverse function of f of x, then something special happens. If you apply f prime to f of x, you get x back. If you apply f to f prime and then apply to x, you also get x back. That makes f prime an inverse of f. But don't you think it is also the same way, the other way around? F is also an inverse of f prime? Yep, it is true. It's like a mirror image. Okay? We just ran out of time. But is everybody convinced that x minus 1 will undo x plus 1?
Yes, you say so.
Yep. Okay. If you have one thing to remember regarding the understanding of inverse function, remember it is undo. It is the undo of the edit menu. It will undo an operation. So we will continue from this point on Thursday. Please read the notes before Thursday. I can see who has read it. And when, and how many times. Maybe I should compile a little table. Yep.
Just wanted to know on that.
Okay.
I think I figured out the homework.
Yeah, the video recording is online.
Yeah,
you
I
can
was
go to
watching it,
YouTube and.
yeah.
Oh, okay, that's good. So was the recording okay? I mean, could you?
Yeah, no, I think I figured it out
Fast
through
in some
there.
parts.
Hmm?
Yeah, we just gotta fast forward and rewind.
Yeah. Made it kind of hard.